Okay, so the first part asks you to represent the constraints mathematically. Table 4, can you just tell me what a constraint is? Like, you don't have to tell me what you put for this word problem, but like, what's a constraint? Or another word for it, a synonym for constraint. Well, you could make an equation. You could use an inequality to represent it mathematically, but constraints are not necessarily like, I guess, limited. So table 5, can you tell me what a constraint is and what your work for maybe? Sorry, one more time. Something that's limiting. So we talked about this right at the beginning of Unit 2, Part 1 as well, when we were talking about how to make equations or expressions. Remember that constraints are limiting factors, essentially. Obstacles is what my first part said. Barriers, whatever you want to call it, but it's something in this real world problem that is limiting you. So full attention, I see our eyes on screens. Don't think we really need much on your screen other than a calculator, so I shouldn't see like gazing at our screen. All right, but you need to, in this little paragraph, find things that are limiting to Kieran's situation. So table 6, what's limiting in his situation? Tell me one thing. Okay, the budget is $60. To represent that mathematically, that could be with numbers, variables, both. It could be just an expression. It could be an equation. It could be an inequality. Table 7, how would you write something about the budget being $60 with that? Okay, so if I were making something longer, so like down here in number 2, when we get to solving it, 60 is a total of some sort. What are totals usually next to? An equal sign and good, or an inequality sign. We're starting to incorporate those. So table 7, do you think, like, if we're talking about a budget of 60, do people have to spend exactly 60? They could spend more or less than it. So something like that. Could they spend exactly 60? And what should go here probably? Doesn't have to be anything else attached to anything else, but like what they're actually spending. How do we want to display that? Can what they're actually spending be different? Can it vary? So we should use a, and which one do you want to use? That's up to you. All of you. All right, so we just have to define the variables because it says, and like on your test, it also said, if you use variables, specify what each one means. So if I'm using X, what does X mean in the situation? So the amount they're spending, basically. You could even add amount spending to stay in budget, under budget. You could spend exactly 60, so that's why we have the equal to part as well. But you can also spend under that amount and still be okay. All right, table 8. What's another constraint in this little paragraph about Kieran's situation? Right. Okay, so it says prepared dishes are sold by the pound at $5.29. So that is something that's limiting, right? Because if, of course, you also have a budget, you can't buy a whole lot if it's going to go over budget. So then how can I represent that constraint with math? Class? How can I represent $5.29 a pound for the prepared dishes? $5.29p, and in this situation, p is representing what? Good. So pounds of prepared dishes. Reading this right now, I know I made a mistake in first hour because I thought in first hour they were just selling it by the dish. So I thought it wasn't by the pound. I even specifically said that. Oh yeah, they're not selling it by the pound. So blah blah blah. They are selling it by the pound with prepared dishes. So things like when you go to Fry's and buy macaroni, they're weighing it and then doing it. Okay, so that's what that means. That will affect something later when I ask you about it. But yeah, that can represent the constraint because however many pounds they are buying will be multiplied by the price. That's generally how stores work. All right, table 9. Are there any other constraints in this? So we cover the budget, we cover the price for the prepared dishes. Is that all he's buying for this dinner? What else is he buying? The sparkling water. And the reason why that's a constraint is because it does play into the budget, right? Like he needs to factor that in. Now, do we know how many bottles he's buying? It does say. So earlier when people were telling me this constraint, they said 249s, which can work if you're just talking about like in general. That's how much it costs per bottle of sparkling water. But we do actually know how many he's buying. So since that is not changing, maybe I don't want to use a variable. Maybe I want to use a constant. Questions there? Okay. Now, I don't think there's any others. Reread it a few times if you need to. Number 2 says, how many pounds of prepared dishes can he buy? Do we have enough information to be able to figure that out? Yeah, there's only one unknown, and that's the pounds of prepared dishes. So you can combine all of these constraints because if these are all limiting factors, and they should all probably be in whatever you're trying to solve. And what do I usually tell you is a good place to start? No. No, I mean like when you're making a inequality or equation, what's a good thing to identify first? The total. All right, because that's the budget, that's like the main thing going on, I guess. And the other things contribute to whether they're staying under budget or not. So now we have this one covered. We need to incorporate this into here. So table 1, how would you write these constraints to make this something I can solve?
Go back.
Okay, combine means what in math? Okay, so maybe if I just combine my constraints, my expressions, like this, 5.29p plus, I don't really want to use this one because then I'll have 2 unknowns and we actually know how many he's buying. plus 249 times 2, that makes one inequality with all of our constraints, right? I feel like we were confused on what I was asking. But like, do you see how we included all the constraints now? Now this is something you can solve. So if you didn't solve it yet, I'm sure there's probably some of you that did, because this is really similar to the last unit with just that one minor difference. If you haven't solved it yet, I'm going to give you about a minute. And then I'll start asking groups for my next steps. Okay, so table 2, can you tell me what I should do first in this inequality to start solving it? Either give me the first step for this one, or just tell me what the first step I had to write down in the first step. Okay. So Chris, Ivory, Bill, Bella. All right, guys, can we all take out our notes from yesterday? Because this isn't something brand new. We've been talking about it even since last event as well. So yesterday we did 2.19. There was a part where I had to write out the steps for solving inequalities. Not all the time will you have to do each step, but you can in that order, and then you can't really do that wrong. Table 2, what's the first step in solving inequalities? Distribute if necessary. So class, if I were to distribute, what needs to be in the problem? Parentheses. I do have some here. I mean, granted, normally you're probably not used to seeing distributing where it's just like this one term, but you can distribute to 3 terms, 4 terms. So you can distribute in one term essentially too. As long as it's like a number outside parentheses being multiplied, you typically will do that first, which makes sense. If I want to isolate P and we're starting with what's farther, I'm not going to divide 2 on each side. Like that's not what I'm going to do. I'm going to multiply this together first and then get rid of it later. So class, what is 2.49 times 2? Okay, good. And that does technically count as distributing, taking an outside number, multiplying it by the term inside. After distributing, table 3, what do we check for? If there's any like terms to combine. Do I have any on the left side to combine? No. So then move on to the next step, which is move variable to one side. Table 4, do I have to move a variable to one side or is it already on one side? Okay, great. So then we're going to go to the very last step, which is isolate the variable. That's where it's more like what we did on Monday, where you look at what's being done to the variable and start with what's farther. So table 4, what is farther from the P right now? The 5.29 or the 4.98? But we want to cancel it out. Table 5, how would I cancel out the 4.98? Good. Whatever you do on one side of the symbol. Good. We're relating it back to the real world. We already know what they're spending on the sparkling water, so we already have to take that out of our budget. So class 60 minus 4.98 is 55.02. All right. What we were trying to figure out is how many pounds of prepared dishes he could buy. Knowing that we already spent some money on the sparkling water, this is what we have left in our budget. Table 6, how do I get the P fully by itself? 5. Okay, great. So then we have the same thing on top and bottom of the fraction. It cancels. 1 times P is just P. And do I need to flip the sign for that? No, because I divided a positive. So you just leave it how it was given to you, less than or equal to. Work out that math in your calculator. And class, what does it end up being? About 10.4. Doesn't say what to round to, but this being your final answer this year. All right, so that's how you solve it. From making it all the way down to isolating the variable, we are going to practice that today with some more challenging inequalities. Because on your unit tests, there are some that are kind of challenging. On your final, there are some that are kind of challenging. But if you follow those steps that we explicitly wrote out yesterday, then I think you should all be able to solve it. Okay, so we're gonna go over that today. Real quick before we continue. Is he able to buy 10.4 pounds? Like, is it possible to have a decimal of a pound? Yeah. Yes. So this is possible. It is reasonable. Earlier in first hour, I thought I didn't know it said pounds. I thought it was just like dishes, like here's 1 dish, here's 2 dish. I thought there could be no decimals then, but I realize now it does say by the pound. So that is a reasonable answer. You can buy exactly 10.4. What is the minimum amount you can buy? 0. Or if you're wondering, because that can be kind of tricky with the real world situation, it says he wants to buy some prepared dishes, so why would he buy 0? Like, I know that can be some people. I would say anything above 0, even if it's like 0.01. All right, why he would buy that much, I don't know. But depending on what practice you're doing, it might say 0 is the minimum, it might say 1 is the minimum. So just be aware of that. But you know he can't buy negative, right? Can't buy negative pounds. Even though that's less than or equal to 10.4, that's like not reasonable. Okay, keep that in mind. Good. Today we are still writing and solving inequalities in one variable. Yesterday was more so just solving them and figuring out like solutions or values that make them true. Today we're attaching those real world aspects in it and reminding you how to make expressions, inequalities, equations from scratch. All right, so keep listening to those tips. Identify the totals, identify your limiting factors, think about it logically, all of those things. Things that vary should be variables. Things that are staying the same should be numbers. So things like that. Recording right now, I record all the time if you haven't noticed. The practice is in Schoology for this one, and I already disabled the ones from Unit 2, Part 1. The only thing I never disable from task units are the study guides, because those can help you for the final. But really, like after we've already finished the unit, it's no longer helpful to go back and do those 10 points. At this point, you need to focus on the homeworks we're currently on and the study guides we're currently on. But just like keep in mind, don't let yourself fall behind. We are testing Oh, I need to include the longer version of this list, but we are quizzing tomorrow, and that'll be our only quiz for this unit. And then you are testing for the unit after fall break. So it's a really short one. Don't let yourself fall. Any questions on anything I just said? We're gonna skip the next word problem. We are gonna go right into this, which is not necessarily on your paper. You might recognize this on your paper. But really briefly, I need you to look at how Andre solved this problem and how Priya solved this problem. And make sense of what they did and if it's correct. So just look at it yourself. It's only on the screen. And then talk with your groups. What did they do differently? And is that allowed? Give you about 1 to 2 minutes to discuss with your groups. So table 5. What did they do differently from each other? Okay, so they subtracted the 18 on each side in this one to get this side to just have the negative x. Table 6, can you say what Priya did to go from this step to this step? Okay, and what math did you do to the window? Whatever you do one side. Okay, so that's the difference. Personally, like, well, actually, let me ask them. Are they incorrect in either of their ways of solving? Like, did they make a mistake in subtracting? Did they do something that's not allowed? So both are acceptable ways of solving. They both got the same answer, albeit on different sides, but we know that 3 equals x is the same as doing x equals 3. So both ways are acceptable. What way do you think is probably more recommended, Andre's or Priya? Which way have I recommended to you? Priya's. Again, both ways are not incorrect by any means. They do get the right answer, but it is good practice once you get to something like this after distributing to move the variable to one side first. Before continuing to isolate the x, because when you're isolating the x and they're on both sides, like, I don't know, it just can present some issues if you're not following your math correctly. Although Andre did follow his math correctly, and that's just how it ended up being. He also, instead of moving the smaller x of the two, he decided to move the bigger x of the two, which is still acceptable. Like, that still cancels it out on one side, and he did it to both sides and simplified correctly. But it is recommended when you're moving the variable to one side, which one should you move? Most. So we recommend you move the smallest, because it's less likely you will work with a negative. And we know when we're solving inequalities, so it's kind of weird. I don't know why they made them equations here when we're solving an inequality. But we know that with negatives and inequalities, we have to remember to flip the sign, and we don't want to have to forget, I guess, and get the problem wrong. So you on your paper, good discussion, have a problem similar to what Priya's looks like, and except for it's the actual inequality. So notice that in Priya's steps, at no point did she do one of the things that makes you flip the inequality sign. Table 8, can you tell me when I have to flip the inequality sign? Good. So you might already have it on your notes from yesterday, but if not, you flip the inequality sign only when multiplying or dividing a negative on both sides. All right, if you already remember that, cool. Maybe you don't need to write it again. But if you don't even know what I'm saying, then maybe write it down. So once you start remembering, you remember that rule. As far as the other steps, they are the same as yesterday. So I don't necessarily want to waste time rewriting them. I'm probably just going to copy and paste them from yesterday. So you are more than welcome to either rewrite them if you want, but know that the steps for solving inequalities are the same as equations. You will still distribute first if necessary. Combine like terms if necessary. I don't have to in this one. Move the variable to one side. And then start isolating the variables, starting with what's farthest. Okay. So what you will do now is practice these steps with some that are a little more challenging on the back. So on the back, there's like 4 at the top to work out. Do your best, follow those steps. Then for your cool down, in case you finish early, it has the graph solutions and one that's, I guess, a little more challenging as well. Today's all about like the more challenging ones. Be able to match the inequality to exclusion graph. All right, but we will go over the top 4, I'd say in about 5 minutes. We'll just see how far you get. Questions? Okay. So then practicing those steps, I'm going to copy and paste it so they'll be on the screen shortly, but they're the same as yesterday. Yes. When Cadence comes back. I noticed when I was walking around that a lot of people skipped this one, but I think this one's actually one of the more easy ones. Hold on, what just happened? Is that me? Oh, oops, sorry. Anyway, because in this one, do I need to distribute? Do I need to combine like terms? Do I need to move the variable to one side? All I have to do is isolate the variable. And really, it's only going to take one step. What's that step going to be? How do I cancel out this 1/5 times p? Multiply by the reciprocal. If you also said you divided each side by 1/5, great. Hopefully you use a calculator to do that for this one. But if you're multiplying by the reciprocal, that's the same thing. I mean, it does the same thing. It cancels this out to where it's just p on the left. Do I need to flip the sign at all? No, because I multiplied by a positive, so leave the sign the way it is. And then this I can do without a calculator, but by all means, if you need to put this in the calculator, put the fraction in parentheses and multiply. What's negative 10 times 5? Negative. Wait, what? Let's try that again. Negative 10 times 5. Negative 50. Okay, I thought I heard negative 2 for a second. Negative 50 and then divided by 1 is. What's negative 50 divided by 1? So that one I thought was actually pretty easy. We got to get over this fear of fractions because there will be fractions on your test. Okay, this one would not do that. Question? Okay. Which other one looked difficult? I don't know that we'll be able to go over every single one, but which one looked the hardest? This one? This one? This one? Yeah. Okay, so let's look at that one first then. And remember the steps. I don't have them on my screen, so let's just see if we remember if we can use our notes the right way. Remember, you can use notes on your quiz tomorrow, just not on your unit test. But eventually have them. In this one, do I need to distribute? Yes. I have parentheses over here. It's a number outside being multiplied by the parentheses, so I am going to distribute to each term and multiply. Table 9, can you tell me what we get from distributing this? Is that all? Close. Class, what's a -2 times -7? So it should be a positive 14. And that's a really common mistake. They will try to trick you. They'll work it out with that mistake in there, and then that'll be one of the answer choices. So don't let it trick you. Remember that the sign in front of each term sticks with that term, and then your integer rules when multiplying. When I have a negative times a positive, what do I get? Listen to what I'm saying. A negative times a positive, I get. And then a negative times a negative, I get. Right. Don't forget. All right, so we distributed. Are there any like terms that I need to combine on either side? No. We do have to move the variable to one side. And right now, that's not so easy to do because this variable is a part of a fraction. So our goal is still to move it to one side, but I need to break up that fraction first. How can you make any fraction not a fraction anymore? So the question was, how can I make any fraction not a fraction anymore? Times it by, well, I don't want it to cancel out to 1. I want it to cancel the denominator. So if I multiply by the denominator, that will make it just C on the level. So any fraction can be broken apart by multiplying the denominator. This time I don't want to cancel it out. Okay. On that. Did I multiply or divide the negative on both sides? So don't flip the sign. Leave it how it is. And whatever you do one side, you have to do to the other. You have to multiply this entire side by 3. So do that. Table 8, can you tell me what I get from distributing this? -6. See. But be afraid to use a calculator. I don't even know that off the top of my head. But class 14 times 3 is 42. Okay, good. It's a positive times a positive, so this is a positive. All right, now we can more effectively move the variable to one side now that this is no longer a fraction. Which one do we recommend you move? Smaller. So what's smaller, C or -6C? And how would I cancel that? That's what we're gonna do. That way I don't have to work with the negative later. But it's up to you. If you did it a little bit differently, you'll see if you got it right. Class with C plus 6C. I don't need to flip the sign when I add. So I get 7C less than 42. What is opposite of multiplying by 7? Whatever you do on one side. And I didn't multiply or divide a negative, so don't flip your sign, leave it how it was given. What's 42 divided by 7? Good. So I'm telling you now, you will have a problem on your test, your unit test, that you might want to break up a fraction by multiplying by the denominator. It becomes a lot easier. Questions? All right, we might have time for one more. So do you want to see the one that's above this or the other one? Like not this one? I can't tell. Raise your hand if you want to see this. Okay, this one's not that hard, so we'll do it. Maybe we'll do them all. In this one, do I need to distribute? No. Do I need to combine like terms? No. I need to move the variable to one side? No. I do need to isolate the variable though. Look at what's being done to it. It's being multiplied by -9. What is the opposite of that one? Dividing whatever you do on one side. Do I need to flip the sign for that? Yes, because I divided a negative on both sides. But notice that, highlight it if you need to. That's one of the two things that makes it flip. What's 36 divided by -9? Good. All right, the other one's a little longer. Maybe I'll just display that one and give you time to test yourself on the last one. I don't know if there's anything to see on that one. I will say number 5 on this last one looks like something on your test, so maybe like at least match that one appropriately. There's another way you can check your answers, but I'm like a little hesitant to show you. But I feel like if it's gonna be there as a resource, I feel like it's so good to know. I wouldn't use this as a starting place, no. So let's look at the one that we didn't do from that section of 4. And that one already has variables that the calculator likes. So whatever calculator you're using, you have to like know your ins and outs of it. This calculator can only graph when x's or y's. So in this one, it's already an X, but if it was a different problem, I'd probably want to make it an X so that it reads it. I'm typing it in exactly how it looks on my paper. With the inequality sign and everything, there are buttons right here. And then it gives me this. You would have to know how to read this in order to get your answer. But notice that the x-intercept, because we had x as a variable, the x-intercept is -1. That means my final answer will be compared to -1. And look at where it's shaded, because that's where the solution would be. Are these numbers greater or smaller than -1? These x's is where you put. They're greater, right? 2 is greater than -1. 4 is greater than -1. So I would want to make x the greater number in this situation. Let me make that look more like inequality. And then it was given to me with the little line underneath. The little line underneath would never disappear. Sometimes the inequality flips, but if there's a line, it will never disappear. Still be there. So that's how you can check your answers. I mean, it doesn't replace your need for knowing all the steps, because not all the problems want the final answer, but at least you can get some of the points if you know how to do this. Questions, comments, concerns? Okay. So anyway, if you didn't get that for this one, I would recommend looking in Schoology for those steps. If they're not in there, I'll put them in there right now. Highly recommend you try this out, because this will be good practice for your final. But we're not necessarily going over that today. You can use the rest of the time to work on your actual homework or ask questions if you need it.